over here. We have our resource persons, resource person, Mr. Srinivasa Chakravarthy Perala from Vice President, Business and Engineering, Perala Technologies India Limited. We are happy to have you, sir.
Good morning, ma'am.
Yeah. I would like to introduce about our chief guest. He is having overall 21 years of experience in design and development of products in automotive embedded systems across different domains in the area of in-vehicle infotainment systems, VR solutions, intelligent personal assistance, navigation, and media driver development of in-vehicle network bus protocols. He is having various experience over various industries like Dearborn Electronics, Bosch, and Daimler. And his hobbies include playing cricket, tennis, and swimming. Over to you, sir.
Yeah, thank you for the nice introduction about my overall career. Let me click on the. Good morning to everyone. You're able to see me, right?
Yes, sir.
Yeah.
So, but voice is little less. We need a bit louder at home.
Okay. Yeah, now it is better?
Yeah.
Okay. So thanks for the opportunity giving for me to take you through the automotive, evolution from the driver to driverless cars, what is currently happening in the automotive industry. Prior to that, I would like to thank each one of you for like the this is a nice I would say a good opportunity for the people who are there in the colleges basically, because there is a the connect between the corporate and the colleges where like you people are the teaching the student like various topics on the electronics and computer science and different where the technology oriented concepts, whereas the industry is talking about the when the respective candidates engineers comes from out of your colleges, and they will be get familiar with the technologies which are the domains which are working outside the college. So that's where these kind of sessions definitely help to bridge the gap between the particular domain and the technology, and the same time the particular the area of interest where you are currently working on. Definitely it will help to take your students to the next level to explain or to give the real use cases. So that's where I'm very much happy to connect with you to discuss a couple of topics which I know. As the earlier the man told, I have around 21 years of automotive experience, where I was working with different multiple domains like the infotainment, connectivity, ADAS systems, and even today, whatever the autonomous driving. But today, last few years, I have my own the startup where we are building the engineers for the automotive ADAS driving development programs. So with that, I will just give the introduction. So then this particular session, whatever we are going to have another 90 minutes or maybe 1 hour, 60 minutes, it is going to be, I'm not going to talk about any technology. Okay. And I think the previous sessions or maybe the next as per the schedule, I think some of the research scholars are talking about the technology like artificial intelligence and machine learning, data science, and different aspects. But whereas I would like to focus on specific to the domain where the driver to driverless taking us, and when it will be the self-driving car, when you say autonomous car, driverless car, when that will be the realization will happen. So these are the few topics I will cover on. Okay, and basically I am not from electronics background. Sorry to if at all if I make any some mistakes, please excuse me, because I'm purely on computer science guy where I built my expertise on the automotive domain. Okay, and let me share my screen. You're all able to see my screen? You're all able to see my screen, right? Hello? Hello? I'm audible? Hello? I'm audible? Hello? Okay, you are able to see my screen? Hello? Hello?
Yes, sir, you're audible. It's going on.
Yeah, you are able to see my screen?
Yes, screen is also visible.
Oh, yeah. So the topic of the discussion today, the particular thing is the evaluation of automotive the industry from the driver to driverless car. So there we talk about the introduction, what is the driver car and what is the driverless car. And the next which is on the evaluation eras, what is happening from last 20 years to till now and where we are heading towards. And the next one is the autonomous evolution. Like there are different levels of autonomous vehicles which we are rolling out on the road. So what is the status and where we are currently? And the next one is what are the benefits which we are going to get with the driver and the driverless car? And what is the sensor fusion? Like the driverless car, when you are talking about the autonomous or self-driving or driverless cars, it has some data, some sensors, some electronic part needs to be connected to the car and collect the data and make certain decisions. So what are those particular sensor fusion which we are talking today? And the next one is a Q&A session, like where we are open for the forum where we can ask some questions on the respective presentation so that we can discuss and exchange the knowledge between both of us. So that is the agenda today, which is set for the platform. And I would prefer like rather than because I would like to have the face-to-face discussion where in the classroom like kind of a thing. But the slides I use very wherever I present less printing content, but I want to put it on the board and explain the things. But yeah, because of the current corona situation, like we cannot avoid that the online meetings. Yeah. So the introduction is what is the driverless car? So what is a driver enabled car basically? So what is a driver enabled car? I think we all driving is one of the most complicated activities that we usually routinely do, right? Right from start from your home to college or start from home to any entertainment spots or maybe any trucking or any traveling part where you need a car. So that's the most driving part is what where most of the humans routinely does in the daily activities. So we do things like we have an eye contact with others to make the decisions on the road and also to identify the weather conditions because when it is rainy season, then we need to switch on the wipers and we need to when it is a cold season, a hot season, then you need to switch on AC or when it is a cold season, you need to switch on the heater. So these are all things manually to be done by either passengers in the car or in the driver in the car to see the environmental conditions on one part. And the second thing is the road conditions. So when you are going on the road, there are the white lines and the yellow lines which are drawn on the particular road. So where you lanes will be crossed with the particular cars. So this is what one of the usually driver has to do as a manual intervention. If there is no absolutely no automation as of today, and everything is done by as yesterday there is no automation. So everybody has to do in a manual way. But what is the driverless car? So what is the driverless car? So the car is fitted with many of the cameras, many of the sensors to take the to track all the objects around it and react it about the steering wheel, whatever you are going to operate the steering wheel. And for to do this, there is a teach in-car computers the rules of the road and set them loose to navigate their own destination. How you define the rules, your classroom, like student has to be come morning 9 o'clock and leave by 6 o'clock. Similarly, the some set of rules to be defined to the car to take certain decisions, whether you need to go in the right direction or whether you need to do whether what you need to do when you identify an object on the road. So this particular decision has to be taken by a car. So in that direction, you need to have a computers. You need to have a computers which has to be built inside a car. So that's what the particular computer can handle the task, whole task of driving. When it won't, you cannot do it on yourself because there are certain decisions. For example, when you are traveling in the night, you will get a drowsiness. When you get a drowsiness, automatically you try to hit the object which are there in front of you, the car. So the particular human eye cannot detect that. Even though detect it, you are in the drowsiness or in a sleeping state. So that's where somewhere some automation is required to save the lives of the humans traveling in the car. That is where the autonomous driving and as well as the driverless cars are coming to the picture. But the simple description, like to fit a car with the some kind of a computers and track the objects and also to make some decisions. It say like it is a simple sentence, but there is a lot of complexity involved to achieve all these activities which is performed by the in-car computers. So automation and autonomous driving are both are the complex subjects as of today automotive industry is talking about. So automation is a like one is like automate the things whichever is happening in the car. For example, when you are going from one place to another place every day, you know the destination. I need to go to from my house to college or my house to office. That is a fixed distance and a fixed route where you can automate that and say like what is the mileage and what is the particular traffic congestion on that particular road when you are traveling at the same time. This can be done with respect to the automation kind of an activities. But when it comes to autonomous is it's more on making a decisions like either it could be on the infotainment or either it could be the sensors, different sensors which are connected basically in the night vision or in the morning time when you are traveling or when your rain is happening, like when the wipers needs to be on or when the outside temperature is too high, when the air cooler is on inside a car. So these are all the some of the complex things where little bit of software knowledge and algorithm development is required to make these things to happen. So in this, whatever the engineers which are who are writing the code on the labs and in the computers, see, it does not always match the what the end users, marketers in the sense the end users are expecting. So end user now, if you see the car a couple of years back, car is a commodity item where you wanted to use for particular purpose to travel from one place to another place or to use your particular activities when you want to do it. But whereas nowadays car is another home, like you are doing everything else, everything in the car, like you are able to do work in the car, you are able to manage the meetings, you are able to watch the entertainment, you are able to make the phone calls. So what else? You are doing anything, everything, whatever you are doing at home, even you are doing the controlling the home from the car. So home automation is also possible to the from the car because of the autonomous driving and the technology which is taking place in the cars inside a car. So that is where car is no more a commodity item. Car has become a kind of a luxury item, and at the same time, car has become a second home rather than your original home. So this is where the driverless car and as well as the autonomous the functions which are coming into existence to give the different benefits to the driver. At the same time, the autonomous driving also helps the driver to reduce the workload on them, because when they are traveling in the overnight, as of today, partial automation is already available in the existing cars which are there on the Indian roads, not from the Indian makers, but whereas from the Korean makers as well as the European makers, certain ADAS functions, advanced driver assistance, to assist the driver to make certain decisions, and at the same time to reduce the workload for the driver. So these are the particular topics which we are coming to discuss in the next slides. What is the complexity? So the complexity is, see, the the computers which are connected in the car, it has to communicate with other cars to make a decision. That is where the vehicle-to-vehicle communication comes into the picture, which is called V2X. The X can be replaced with anything. X can be V2 home, V2H, or X can be V2I, infrastructure, traffic infrastructure, or V2C, V2 your telephonic towers, and even V2I, vehicle to infrastructure, vehicle to vehicle, vehicle to anything, vehicle to home, or anything you can. V2X, that is called a V2X. X can be replaced with anything. Basically, why you need this kind of a communication between the infrastructure, vehicle to infrastructure, and vehicle to home, and vehicle to the road? Because to identify who are the cyclists who are traveling on the road, and pedestrians when they are crossing the roads, and any obstacles which are there on the roads, to identify and inform the assist the driver to make a better decisions. That is where you need to interact with all these environmental as well as the infrastructure as well as the realistic objects which are moving on the road to make a better decisions to the driver when you say driverless car. So it is hard to get enough training data on the road, because any computer, like even if you fit the sensors today, whatever lidar, radar, or the ultrasonic or cameras, whatever you fit into the vehicle, as a surrounding cameras or LV cameras, but so there is the camera has to identify even your whatever we are using today, the cameras or the mobile phones, it will be trained with some kind of a data. Otherwise, it won't detect the object. For example, there is a pothole on the road. So even though camera is fitted in the car, if the car doesn't know what is that particular object or what is the particular image which is coming from the input to the car, so the car computer has to analyze and make a decision. So that's where you need to have a lot of training data needs to be given. How you use it for speech recognition as well as the voice recognition, the particular data to be trained on the particular language, either it could be male voice or female voice. Similarly, here the objects has to be trained with the computers to make the spontaneous decisions. But whereas as of today, because of the lack of the data, like these are the concepts which are coming newly, the autonomous driving, and the different driving conditions and different road conditions, different weather conditions. So all the data has to be trained with the system to make a better decision. So that's where the complexity involves in that. And when the data is generated, then you need to have some kind of analytics, data analytics you need to perform. So data collection is one part. That is, as of today, GBs of data is available on the vehicle manufacturers, with the vehicle manufacturers as well as in the cloud also. There is a lot of data is available or collected from the past 100 years of automotive industry. But whereas the bigger challenge is facing by the industry today is the data is not structured data. The data is, people are dumped the data like whatever way they whatever the way the device is or vehicle is producing the data. But whereas there is no standardization come across in all the automotive OEMs, it's not only automotive, any other, even healthcare or any other domains. There is no standardization data, structured data, which is available on the respective the stakeholders. So that is where the challenge is facing by current industries to structure the data, and so that the data, whatever so far collected, can utilize to train the system for a better improvement of the human lives. So that is where you see, like today, industry is looking for artificial intelligence engineers, machine learning engineers, and even data science engineers. So this is where the role of this particular engineers. First part is to make the data which is unstructured bring back to the structured waveform by using AI or ML algorithms. And the second thing is whatever data which you are going to collect from today, make it as a structured form and make it as a unique standardization bring into it, so that the future generations will utilize this data, and your existing models will effectively work by using this existing using the trained data. So this is where the current industry is primarily focused on. Everybody is talking about artificial intelligence, machine learning, and data science. Otherwise, these are not the new topics which was there from the ages. Artificial intelligence was there from the ages, data science was there from the ages, and even the machine learning was there from the ages. But only thing is, because of the current the problems which is industry is facing, these are the topics came into limelight, and the people are more focused on the data-driven models rather than a historic way of making the decisions by using the subject rather than making a subjective decisions. They want to make an objective decisions by having the data put it in the right place. So this is where the complexity involved in it. So to reduce this complexity, to overcome this complexity, there are many technologies which are currently working on the automotive industry. One is on either using a Python, which is more predominantly used in the machine learning and artificial intelligence, and another one is the C++ language, where you have the design the models and writing the algorithms in an effective way, where you're using the objective loops concepts, as well as the different data structures which are effectively used, and other the cloud, which is on to put the data back to the cloud, which is Azure, and as well as the AWS and Google Cloud. So there are different stakeholders which are acting, doing their job to make this reality to happen. The one is on the cloud side to carry the data onto the cloud from the vehicles, and other one is the vehicle manufacturers to put the right sensors and the right ECUs in place to collect the data, and other one is the engineers who is performing the software algorithms, effective algorithms with respect to AI or ML to justify the data which is collected from the vehicle and make the decision making at the cloud end as well as the edge computing. So with this, if you see, this complexity is not only involved two parts. One is on whether all ECUs, computers which are fitted on the vehicles, it has to do edge computing, and at the same time it has to do cloud computing as well. So when you are doing edge computing, for example, when you are when you are going on a road with there is some obstacle, there is some, like for example, if you hit by a rock, then automatically the airbag has to open. So if the car has to, one is based on the impact analysis, the airbag will open, and at the same time, if you identify there is an object using your radar or lidar sensor at least 100 meters, 200 meters away, then some decision has to be taken by in-car computer, because it has to alert the driver, say that either it can be it can be in the form of either a warning or it could be alarm. So this has to be generated on the spot itself, spontaneously. This is what the edge computing has to be performed by the computers which are there on the car, and other data like when you are doing the navigation, when you are doing the infotainment, this data can be predicted over cloud. It need not be an edge computing, because this is not no more a safety feature. But whereas the airbag and ABS, these are the safety critical features. So this is what the safety is to, you need to be calculated on the edge computing itself. That is where, if you see nowadays, the cars are coming with GBs of memory inside, and it has a much advanced microprocessors. And if you see the semiconductor companies, for example, NVIDIA and the ST Microelectronics, the current chips, whatever they are making it today, which is predominantly very much suitable for the automotive industry and designed specifically for the ADAS systems to process the data and also connect with the cloud. So here we have a connected car which is having the data to be processed in the cloud, and at the same time the edge computing, where you are trying to manipulate the data and applying some kind of limited algorithms which are given to the embedded space, because embedded systems always works with limited memory capabilities. So this is where the specific things which are save the lives of the humans, those decisions will be taken care by the in-car computers, and all the entertainment which is not a safety critical will be taken care by the cloud computing technologies. So this is what the current automotive industry is focused on. One is on cloud computing, and other one is on edge computing. As per, if you consider for the ADAS, like which is on autonomous driving car functionalities. And when you're seeing the safety features, how it has been evolved from 1950 to 2025 plus, and going forward, what kind of features which we are going to see. So the first one is before 2000, maybe almost some 50 years, from 1950 to 2000. There are three safety features which are, we would say, safety, or maybe here the anti-lock brakes, which is a safety feature, and seat belt is a safety feature. But whereas cruise control, which is a convenience feature, and why it is a convenience is, for example, when you are traveling from Bangalore to Hyderabad and there are 500 kilometers distance, so you can set the cruise control speed because of the highways and because of these are all things, right? Before 1950, the realization was only in outside India, it's Europe and US, because those were the developed countries with respect to the infrastructure, with respect to the technology, and with respect to the cars which they were using that part of the time. So the cruise control, when you set the limit for 100 kilometers per hour, then automatically you hold the steering and relax, so that the vehicle continuously goes at the 100 kilometers per speed. But where still you need to make a decision when the object comes, and when you take a turns, still you need to move the steering wheel and reduce the speed, and automatically again once you pedal the accelerator, it goes to the normal whatever you set the limited speed of 100 kilometers per hour. This is the basic three features which were there in the 1950 and 2000. And when it comes from 2000 to 2010, the next 10 years, this is what the actual evaluation starts with respect to the electronic control units which are using in the cars. One is on electronic stability control and blind spot detection, forward collision warning, and lane departure warnings. Basically, these are all with respect to the road conditions when you are driving a car at 200 kilometers per hour. And what is the stability? Electronic stability, which is the vehicle which is making either, now it is called as electronic power steering, EPS, and as well as electronic stability control. And blind spots. Blind spot is like whenever you find a path hole or where the vehicle road ends that particular direction. This kind of detector should be done by through some of the sensors which are connected to the car. And forward collision warning, say when you are crossing the car, moving forward, any collision happens, then you are going to hit the car, another car which is coming in the opposite direction. So these kind of decisions which can be given by the in-car computers to the driver in the particular 2000 to 2010. And when it comes to 2010 to 2016, this is where the partial driver assistance features are coming into the picture. One is like rear view systems. For example, when you are traveling, when you are traveling on the road, you would have seen a big trucks where it is carrying the multiple loads of the material. So, but the driver who is driving the truck, he will not know what is happening in the behind the vehicle. So that is where the rear view videos are fitted onto the truck, so that the driver who is driving the big truck, he can see what is coming in the back, and when he has to give the side for the backside vehicles, and at the same time he can pass on the indications which is coming, because the backside driver coming in the car may not be knowing what is happening in the front, because this is a heavy lengthy truck. So that's the reason the particular driver driving the truck give the directions, both the back end person as well as the person who is driving the car as well. So this is where the rear view systems are coming into the picture. And automatic emergency braking, which is like whenever you hit the you are going to hit the object, when your driver is on drowsiness or you are not able to make any decisions, automatically system takes the decision and applies the brake on its own. That is where the automatic emergency braking has come into the picture. And pedestrian automatic emergency braking. Pedestrian is like when the person is crossing the road. The person is crossing the road, and the as a driver you are not able to make any decision. Automatically the sensors apply the brake and save the life of the particular person. And rear automatic emergency braking, same as the front wheel and the brake, whatever object which you are seeing in the back, based on the things you can avoid the collision. and traffic alerts and lane centering assist, because in India we have only the lanes which are there, the white lines and the yellow lines, and the vehicle which whenever you are crossing the particular lines, so either white line or yellow line or maybe whatever lines which are there on the road, the particular decision will be given by the in-car computer to make the driver assistance systems. And when it comes to 2016 to 2025, this is where the partial automated safety features, which is on lane keeping assist and adaptive cruise control, traffic jam assist, and self park. So here it is where you can the vehicle can park on its own based on the directions given by the in-car computers, and some of the through mobile also you can ask the vehicle to park in particular place. That is what the parking can be done. And adaptive cruise control, which is the based on the speed, based on the road conditions, automatically. Earlier in the 1950 and 2000, the cruise control is like whenever you set the speed of 100 kilometers per hour, it automatically goes, and the driver has to take certain decisions when they are crossing the roads, when they are changing the lanes or changing the particular curving the roads. But whereas in the adaptive cruise control, whenever certain you need to take the diversion, automatically the speed comes down. So driver no need to act anything on the speed part, acceleration part. So that's where the adaptive cruise control comes to the picture. And the next is the traffic jam assist. This is the traffic jam. I think we are in Bangalore, we are very much aware of the traffic jams, how it is happening on the road. But whereas if you look into the real the traffic jams, the decisions which is taken by European as well as the US, there it is traffic lights operates based on the density of the traffic, not on the timer signals. Like in India, we see every traffic signal have a 5 minutes, 3 minutes, 2 minute signal, irrespective of the density of the traffic. But whereas in US and Europe, it is on density of the traffic. Like the monitors, the cameras which are fitted onto the traffic poles, they keep monitoring the vehicles which are coming on the road, and these are interconnected with the traffic control system. And at the same time, so the particular vehicle, particular road is empty, then automatically it is a green signal which is popped up, and the particular vehicle will be moved up. They don't need to wait for so long to until unless there is no traffic. So this is where the traffic jam assist is coming into the picture, and at the same time it gives the particular road when you are traveling, how much time it takes you to take to the your source to destination, and where the traffic blocks are there. So these kind of information which will be passed on. How this happening? Because of the cameras which are connected to the traffic poles. So as we discussed earlier, these are all happening with the V2X, vehicle to vehicle communication. Similarly, here the vehicle is communicating with the traffic infrastructure, wherever the traffic computers or algorithms are residing on the data centers. Usually, when the vehicle wants to communicate with the other vehicles in the roads, at least every 50 kilometers and every 100 kilometers, there are the data centers which are being set up by the particular car manufacturers as well as the telephone operators. So like the telephone towers, it will be there. So in the towers, the particular the data servers will be installed, and the server's responsibility is to collect the data from different sources which are coming to either one is the traffic poles, and next one is the ambulance information, and the next one is the any other VIP passing on the roads. So these kind of information will be collected by the data centers, and it will, whenever whoever is the general public coming onto the road, it will be informed to over the air through either GSM SIM which are fitted into your respective cars. So the ECUs or infotainment systems are fitted with your connectivity module, where the connectivity module responsibility is collect the data from different vehicle infrastructure modules and make the decisions and assist the drivers in the direction. So that is where the particular data centers which are fitting onto the roads to address the different autonomous features. And what is the next when 2025 plus? Right now till 2025, the car is not fully autonomous. Even though you say like Tesla is saying today, we are launching a self-driving car and we have experimented it, and we have taken some people from California to hospital without any driver. Even though they claim it is a self-driving car, but there are other cases like there are many accidents because the computer cannot make as we said earlier, it cannot make eye contact with anybody. Like it is not a human. So we are trying to make the computer act as a human. That is where we are currently in, to bring the human touch to the computers to make the driverless car. So that is where the current challenge and complexity involved to make the fully autonomous rather than a partial autonomous, because partially we are seeing it today. Even any small car you take it, even Maruti car 800 or Maruti whatever you are having today, Hyundai cars or Tata cars, they have certain features, like one is on the lane departure warnings it will display, and ABS it will display, and the airbag it will do it. And there are some partial things are already available in the Indian cars as well. But whereas when it goes to the fully autonomous, that is one of the complexities which comes in. Like the computer cannot make a decision as human. So that is where the autopilot, which is there in the like right now the flights operates with the autopilot. Though even though pilots are in place in the cockpit, but still the autopilot operates from the air traffic control ATC system. But still pilots are required to control the flight when it is landing and when it is takeoff. But this technology was there from almost ages in the aircraft system. But whereas if they want to bring it to the automotive industry as well, it is the same. Like you need to have somebody to react to the decisions which is given by your in-car computers, and accordingly you need to make a decision. So that is where the total industry and experts and the respective domain experts are working to bring the theory-based self-driving cars to practical-based autonomous car. So that is where like there are many researches are happening with respect to the features and with respect to the technology and with respect to the how to effectively use the particular vehicle network architecture. So if you know, as of today, there are 4 domains which are exist in the automotive industry, automotive vehicle, which is on powertrain, and next one is a body, chassis, and in another one is unassigned today. So this is called as a PBUC, powertrain, body, chassis, and unassigned. So in these are all the each domain, powertrain is having different engine control modules, ECMs, and different translation TCMs. So these are all will be there in the powertrain. All your body, like the windows, power windows, door control modules, these are all will be there as part of the body control modules, and your chassis and which are connected to the wheels, and those are will be there as part of the chassis modules there. But these are all, as of today, as of yesterday, I would say, these are all working on as individual contributors in the car to make the send the data as well as to make the decisions by the head unit, which is connected in the car, as a ECM is the heart of the particular vehicle. And now because of the EV powertrain, the BMS is the main battery management system, is the main heart of the particular car to make the decisions or to roll out the information to the rest of the ECS in the car. But now the new concept, which is to conceptualize as well as the to bring the reality, which is autonomous driving, is called the domain controller. Like now earlier, like if you see the infotainment as a one unit where you do audio video systems, and one where is the connectivity module, which is connecting your car to the external world, which is a built-in with GSM and the automotive CAN protocol, which is operated in the car, and the other microcontrollers, either ST microelectronics or Infineon. So these are the microcontrollers. There is a small module which we call it as a connectivity module, which is where the MG Hector today they are the talking like internet of the car, internet enabled car. So internet enabled car means nothing. It's just like connecting you to the external world to play the songs or to play to chat with your Facebook or to do the LinkedIn updates or whatever you do social media content, as well as the listening the songs from different sources in the internet. So that is where the connectivity module, which is a small piece of the module which was there in the car to make the car as internet enabled. Now, because of the domain controller concept, like bringing all the different parts of the ECUs, make it as a single controller, and the controller responsibility is to make decisions within themselves and the guide the particular system to move forward. So this is where the domain controllers, that's where the complexity is reducing, and also the complexity of wiring harness is reducing. At the same time, complexity of engineering is increasing. The engineering is like now earlier there is a single core, like even when we are working with the computers, it is a single core operating systems and single core processors which are coming in. But whereas now it is a multi-core, like you have dual core and triple core and many multi-core operating systems are coming now, multi-core processors are coming now. So the same multi-core technology which is there already coming into the automotive industry to basically to why this particular technologies and different cores and different huge memory and high-end processors are required in the automotive industry is to process the data which is collected by the vehicle. So it is an enormous data which is collecting by the vehicles today. It is TBs of data. Even if you monitor data for 1 hour for the autonomous car and current cars today, it is generating huge amount of the data where the processing is highly complicated inside a car. That is where the cloud computing has come into the picture to process the data. So that is where the complexity involves to make a fully autonomous vehicle. But that is where the industry is moving towards to reach the fully autonomous vehicles. And if you see the next, this is where the autonomous evolution happens. There are 5 levels. So one is on the zero no automation, where they like completely driver controls the car and no further in-car computer which can help him to take any decisions. He's a fully driver is the king of the car here. And when it comes to the driver assistance, there it is the level 1 automation, where the vehicle is controlled by the driver, but some driving assisted features like whatever defined in the design of the particular vehicle. So that will be talking in the next slide. And third, level 2 is a partial automation, because here the vehicle is combined with the acceleration, steering wheels, where the electronic power steering and electronic stability control. So these kind of certain features which are there, which has become a partial automation. And a conditional automation, where here even 0, 1, 2, 3, level 0, level 1, level 2, level 3, driver is a mandatory, driver is a necessary guy who has to drive the vehicle based on the level of automation, level of feature, like when there are lane departure warnings in level 1 and level 2, it could be blind spot detection, and maybe level 3 could be a cruise control, adaptive cruise control. And right now if you see in a car like the headlights, which is called a traditional conventional headlights. So when you are taking a turn, the headlight will not move. Only the your steering wheel will move, and at the same time your wheels will move to go to the particular route. But whereas the current, which is called adaptive lighting, so adaptive lighting, the ECUs which are coming in the market, which are already there in the couple of high-end cars, where you move the vehicle, the steering wheel automatically when the vehicle wheels moves, and your lighting also moves there. So that what happens in that case, it will give a better clarity, better visibility to the driver to turn the vehicle and move into the direction. That is where the adaptive lighting is coming into picture. And the same thing, adaptive wipers. Wipers is like automatic when the rain happens. When rain, automatically your windshield, the wiper start moving the cleaning the wiper windshield, so that your driving will be easy. So this kind of certain partial, as well as the wherever it is possible, it is currently as a fully automated, fully autonomous, and fully automated is available. But wherever it is not possible, still it is in a partial condition. So where you say level 4 is what, like whatever we say is combined, like the automatic wipers, adaptive lightings, and even the cruise controls and the lane departure warnings, and even the blind spot detections, and these kind of things already as a fully automated. But where is the driver? Still, the driver is needed in the level 4 automation as well. So currently, as of today, even the people talk about we are at level 4 and level 5, but 99% of the vehicle OEMs, vehicle manufacturers are still at level 3, because they could not able to move from level 3 to level 4 because of they could not able to convert the complete human touch to the computer mechanical way or electronics way. So that's where still we are in the level 3 autonomous systems, but level 4, level 5 is reality, but a distance reality. Still, there are certain features which needs to be fulfilled by the level 4, and as well as the level 5, it is a fully autonomous, which is called an autopilot system. Okay. And this is where the when you go for in detail description about the each levels. The level 0, the human driver does all the driving in the car, and he make all the decision on his own. So as of today, even though there are some accidents happening, when you compare with the driver and driverless. So when you are going for a driverless as of today level 3 automation, so the as of 2020 from the US. The statistics say that 87% of the accidents and 87% of the human lives are saved during the journeys. So that is where the level 3 automation is helping already to the vehicle owners in one way. And when it comes to the level 1, an advanced driver assistance systems on the vehicle can sometimes assist the human driver, either steering or braking or accelerating. This is where you see the cruise control and adaptive anti-lock brake systems. But this will not happen simultaneously. It will happen at only one feature at a time. This is what the level 1 we are at. And when it comes to the level 2, which is on the to control both the steering as well as the accelerating, and the human driver must continue to pay full attention here as well. For example, even though the adaptive cruise control as well as the particular anti-lock brake system is still controlled by the vehicle computers, but still the driving environment and other vehicle health conditions has to be monitored by the particular driver in the level 2 system as well. And when it comes to the level 3 system, which is it is called as an ADS. Earlier it is Advanced Driver Assistance System, but this is an automated driving system, ADS. So in this vehicle itself can perform the certain tasks, okay, under certain conditions. For example, because of the connectivity module, which are connected into the vehicle as a separate small ECU, and that ECU will communicate with the external world. For example, it will connect with your weather condition board and takes the latest weather updates and gives the driver say that this particular road is raining, so you want to move forward or not. So these kind of certain decisions which are taken care by the level 3 systems, and also the warnings like blind spot and the lane departure warnings, self parking. So these kind of certain things are taken care by the level 3 autonomous systems. When it goes to level 4, it is a complete perform all the driving tasks, and also it's monitoring the driving environment. For example, driver drowsiness, because the car cameras are fitted inside a cabin, and it will monitor the driver drowsiness. And at the same time, it will wake the rest of the passengers in the car when the driver goes for a sleep. And when the driver goes for a sleep, automatically applying the brakes and automatically take the car to side path, and it will stop the vehicle. So these kind of certain features will be taken care by the level 4 system. So even if you reach level 4, that is very high achievement, because it will reduce the accidents first time, save the human lives, and at the same time reduce the workload on the driver as well. So these are the certain features which are already people are in the production programs for the level 4. But when it comes to the level 5, it is just like what you are realizing today as a self-driving car. Like when you sit in the car, you don't need to touch the steering wheel. just switch on the engine and you can relax. You can watch your movies, or you can play mobile games, or you can do whatever you want in the car, but without touching the steering wheel. That is where the particular autonomous and self-driving car coming to the picture in the level 5. So this will be a reality by 2025 plus onwards. Maybe by 2030 you can see the fully autonomous vehicle where you feel like you are sitting in a movie theater where you are watching rest of the things rather than a car behavior. So that is where the people are working towards in the autonomous driving. And when it comes to the benefits with respect to the safety, so automated vehicles save the lives and reduce the injuries. So rapid in critical and tragic fact. And automated vehicles have the potential to remove human error, because that's what I said. The simple example is drowsiness, and where we can avoid the crash, and which will help protect the drivers and passengers, and as well as the bicyclists and pedestrians as well. So when the our car is able to identify this object, this is a bicycle or this is a pedestrian, so that the particular collision can avoid. At the same time, the lives of the people can be saved. And another one is which is on efficiency and convenience, because roads, all the roads, whatever the reality comes in, and we have all the automated and autonomous vehicles. So the traffic can be avoided, traffic congestion can be avoided, and the destination between the time between the source and destination can be drastically reduced. And either it could be fuel performance, and as well as the battery performance. If it is EV powertrain, which is the battery performance can be improved there. And if you there is some statistics, so Americans spent an estimated 6.9 billion hours in traffic delays in 2020. So cutting a time at work or with family, or increasing the fuel cost and vehicle emission, which is a major factor contributing to the pollution, which is an emission related, the carbon monoxide which is releasing from the vehicles. So this is where, like, if you see the statistics itself clearly shows the 6.9 billion hours only during the commutation, like either from office to home, or home to entertainment spots, or wherever they are going. So this much is the time is consuming because of the traffic. So this can be avoided, so that the journey will be smooth. And with automated vehicles, the time and money spent commuting could be better used. For example, yeah, as the previous second part, like when you are spending too much time in the traffic, switching on the engine, and lot of fuel and a lot of money to fill the fuel, either refuel or charging the battery. So these kind of things can be avoided when it comes to the efficiency as well as the convenience. It is more autonomous vehicles is more efficient when it comes to the decision making, and it is more convenience to also, because of the you are reducing the effort and reducing the delays, and things will be moving faster when it comes to autonomous vehicles when you are traveling. So these are the major two benefits which we can see. There are many other benefits. One is on environmental, like you can autonomous will contribute to zero pollution because of the EV powertrain today. But whereas in the diesel, but the pollution will be reduced. It will not be zero, but still certain extent it can be bring it down. And at the same time, the other environmental, like whenever if you know in advance, like this particular destination has some kind of weather report during the maybe start of the journey, you may not be knowing what is the weather report, but when during the journey, when you want to know like sudden weather conditions are impacting your journey, then you can cut down your journey and back to home. So that's where it will be helpful for the autonomous driving for the passengers as well as the drivers, as well as the eco friendly environment, like the ecosystem. Like in the road, if there are 100 vehicles are going in, so each vehicle can exchange the information to talk to each other and make the decisions better. And when you say how 100 vehicles are connected on the road, how 100 vehicles can be talking to each other, that is where the vehicle to vehicle communication happens there. For example, when you are traveling with your friends on 4 or 5 vehicles, and you can able to control the speed of the other vehicle, your friend vehicle, from your car. So if your friend is not going at 80 kilometers, you wanted to go at 100 kilometers, and you can bring that vehicle to 100 kilometers, so you both can travel together with 100 kilometers per hour. So that's where the vehicle-to-vehicle communication is a major contributor for the autonomous driving, and as well as the certain convenience. It will make certain convenience to the trucks as well as the passenger cars as well, because the B2B is more helpful for the truck industry, because if you see on the roads, majority of the trucks will go as a group, like carrying the big loads. The big trucks like 20 tires, 30 tires, 40 tires trucks will go as a group. So that way each person need not communicate over a handy phone or any other medium, but whereas through vehicle-to-vehicle communication, he can communicate to the next truck what is where we need to stop and what is the problem which we are facing. So all the vehicle health conditions as well as the vehicle directions can be controlled by the B2B technology there. That's where it gives the convenience for the majorly in the truck industry. But in the passenger cars, yeah, slowly the use cases and the importance of the particular B2B is slowly evolving in the passenger car segment as well. And when it comes to sensor fusion, like whatever we have spoken today, just before, like all the decision making and the autonomous driving reality, but still there are certain electronic parts needs to be connected to the car to make certain decisions. So that is called, one is a radar, next one is a lidar, computer vision, ultrasonic, and camera. So these are the 5 parts as of today available which are connected to the car to make the decisions, to make the night vision visible, and also to detect the objects, which is called an object detection. Okay, so what is sensor fusion? Sensor fusion is the ability to bring together inputs from multiple sources. The source can be either radar, lidar, or vision, whatever sensor it is. So it takes the data from these particular sources, and it form a model like to train the system. This is what we predominantly do at the bench level in the organizations where the people are engineers are developing the software by taking the different images from the different aspects of the car. Okay, where the based on the sensor fitment. So and they built a model, and that model finally trained to the camera, and there is if you see there are huge test drives happens to collect the data on the road, to identify the object, to analyze the object, to know the behavior of the object. And if you see when you are going on the road, if there is some blast happens, as of today we can hear the sound, what is the sound, but we don't know what happened really there, whether it is a bomb blast or whether it is some vehicle collision happened. So this kind of detection we are not there today when you are traveling in the car. But whereas this particular object detection and as well as the object identification, detection and identification, both are is going to be happening with respect to the 5 sensors which are connected in the vehicle, and process the data, analyze the data, and use the trained data, whatever trained by this particular systems, and it will make the decisions to the end users. So this is the major topic which all the industries are working on. Even if you see all in the current the industries like even Bosch, Continental, and Aptiv. So everybody is working on one or the other sensor. Not single one is perfect in all the sensors, but they based on their capability and expertise, it is working on the. If you go into the next slide, so this is what the capability of each sensor. Like one is a radar, basically it is used for long range sensing and object movement and all weather performance. This is what the particular signal is used, and the strength, when the object detection is there, radar has the full strength, and the camera and fusion, which is camera which has capable for object detection, but not efficient way of doing it. So that is where the particular different sensors, one is radar, lidar, and camera, and respective their particular the future. For example, if you say lidar is recent thing which is coming in last 3-4 years, which is very precisely identify the 3D objects and the range accuracy. It gives the very accurate prediction with respect to the object detected on the road, and it works in the night also. That is what their particular night vision is improved in the particular radar sensor. And when it comes to the camera, so camera is basically how our regular cameras works. When you are taking the picture and you can see the classification, say that this is a human, this is the animal, and this is another non-movable object. So this kind of classification can be done with the camera, and it is also do the positions, like when the particular when the object is moving or not, and object is a standstill. So these kind of decisions to take the data and make the respective decisions. But entire the sensor fusion, the sensors primary part is to collect the data from the different sources that are coming onto the available on the road, whether it is object, whether it is a human, whether it is a pedestrian, whether it is a cyclist, whether it is another vehicle, whatever it is. So the primary objective of these sensors is to collect the data. But who is going to process this data? How this data is coming back to your system and to the driver to make particular decisions. So once the data is collected from the respective vehicles, so there is, I think the automotive. In the automotive, there is a different set of protocols. One is on CAN, which is predominantly used by last 20-25 years, and the next one is the most. And the recent people are talking about the Ethernet and as well as the CAN FD, which is on fixed data length, CAN fixed data length. So all the sensors which are collected the data, this is processed by, as of today, the CAN, because I would say partially as of today, but as of yesterday, it was completely, the data is processed over a CAN. But because of the speed limitations with respect to the CAN protocol, CAN has only maximum 1 Mbps speed, where it can travel the data from one place to the one ECU to the another ECU. But because of the data, as you see, as we are continuously discussing, this particular data which is collecting, it is a huge data, GBs of data. So this data CAN is not sufficient to carry forward this data and to make a better decisions. That is where today the people are talking about Ethernet, which has a much higher speed and has a capable of taking a huge data and has a high process throughput power and as well as the high process capability. So that is where Ethernet is coming into the vehicle networks. When the Ethernet coming into the vehicle network, it's just like your LAN in your labs, computer labs. How each computer is connected to the LAN over TCP/IP protocol using an Ethernet cable. Similarly, in the car also, all in-car computers which are there as ECUs, electronic control units, which will be connected over Ethernet cable and exchange the data, and the data will be sent back to the cloud to process further. So that is where the sensor fusion happens there. Sensor fusion is collecting all the data from multiple sources and giving back to the system, in-car computer. The in-car computer will classify data comes from the cameras, take the data from lidars, take the data from radars, and process the data and segment the data. So segment the data in the sense like which control unit has to react based on the data collected from these sensors. So this data is collected by car computers and process the data, either it is an edge computing or whether it could be on cloud computing, and take the results back and feed back to the respective systems to act further. So this is where the entire sensor fusion applies. But the electronic parts involves only their dedicated, designated roles and responsibility. For example, radar responsibility is to sensing the long range objects and to check the object movement. And similarly, lidar is, which is predominantly for the 3D object detection and majorly on the night vision detections. And camera is to classify the objects and inform the system, say that this is a kind of an object, you do whatever you want. That is camera, the responsibility is to collect the data and give it back to the system. And rest of the part, which is what the engineers where they apply algorithms, either it could be ML algorithms or AI algorithms or maybe the lane departure algorithms, which is a lambda equations. So these kind of different mathematics algorithms applies there and make the decisions to give the driver assistance, to give the information to the driver. So this is where the entire the sensor fusion works here. But this is the current automotive industry, and autonomous driving is around these features. One is radar, lidar, camera, and there are other two sensors, which is an ultrasonic. Okay, and another one is a vision, which is what we have already in the computer science, which is a computer vision. The similar thing is there in the automotive industry as well. So all five sensors together is called as a fusion, where you can combine the data and make the decisions and make the life safer. That is what the computer entire the journey goes from driver to driverless car. So these are the basic electronic parts which are majorly contributors to make the drivers as well as the passenger life safe. And this is where the technologies, anyway, the supported technologies, this is only the domain wise, like whatever we are discussing. But the technology wise, there are different technologies like the cloud and the Java, C++, C, and even the Python nowadays people are using for automations which are there in the vehicle environment. And these are the domains which are connected with the technology. So that is where if we are able to connect the technology with the domain, so then it will be easy for the person who are trying to develop this particular software, because as of today many of the if you see the industry, people work on the technology but keep changing the domains, and they may not understand the current whatever they are currently working on the particular the domain from A to Z. So that is where the problem comes in. So if you stick to one domain and if you understand the apply the technology whatever you learned it on the respective domains, so then you will be having a great future with respect to the career development. So this is where we have as part of the sensor fusion. And the next is the question and answers. So whatever the topics which we have discussed so far. So if you have any questions, yeah, definitely I'm happy to address.
Participants, if you have any questions, you can post over here.
Sir, what is the role of dirt parameter?
What is that?
What is the role of dirt parameter?
Dirt parameter.
Yeah.
That parameter means which context this particular question is, because I am not getting that.
In the last slide, it was mentioned, no? Object detection and all.
Which is a dirt parameter. Okay, so this
dirt.
Okay, this particular dot is which is used in the road itself. Okay, the particular to measure it works on the combination of velocity and as well as the momentum. So those together it works as a dot to identify the particular object. It is basically more on the object detection part. Okay, what kind of an object it is, whether it is a movable object or a non-movable object, and what is the 3D surface of the particular object. That is where it is used in the dirt parameters there.
Yeah, thank you, sir.
But there are no queries, sir. So I would like to thank Srinivasa for presenting the session, and thanks for sharing your knowledge as well as spending some time with us.
Yeah, I'm
Thank
glad
you,
to.
sir.
Yeah, I'm very much happy to share the particular session. So in future, if you need any help, please contact me. I have you have my number as well as my email ID. So I'm happy to assist you there.
Yeah, sir. It was a great pleasure. Thank you, sir.
Thank you.